These are Algebra Notes 4.4, and today we're going to be solving systems of by substitution. And so far in our lessons, we have just been setting up our systems, figuring out which two equations we wanted to use. Today we're going to take those two equations and we're going to solve them. Now, as it says, this is going to be using a method called substitution. And before I get into the math, I wanted you to think about something. I was thinking about making a pie, and I saw this recipe online for a chestnut pie, and this is what it said. Use 2 cups of sugar, 1 cup of buttermilk, a teaspoon of vanilla, and 3 eggs. And so I was thinking, I have sugar, I have vanilla, and I have eggs in my house, but I didn't have buttermilk. And I'm like, oh no, what can I do about that? So I went out onto the internet, and I found out that there's a substitute for buttermilk. If you take 1 cup of milk and add 1 tablespoon of lemon juice or 1 tablespoon of vinegar and wait 5 or 10 minutes, you can use that in place of buttermilk. So what I would do was, instead of using this 1 cup of buttermilk, I would substitute this, because I had regular milk and I had lemon juice in my house. I could make this. So instead of using this, I'm going to replace the buttermilk with this substitute. So I would put 2 cups of sugar, and then I would put this, the vanilla and eggs, and I could make my pie. So that's what substituting means. We're going to take something that we're not going to use, we're going to take it out, and we're going to replace it with something else. That's what we mean by substituting. So let's look how that works with math. Okay? So here are our notes. We have these two equations, x equals 5 and x plus y equals 12. Now, step 1 is to what we call isolate a variable. And when I say isolate a variable, sorry, my pen's not working real well. That means get the x or the y by itself. I'm really sorry about this pen. It's just not cooperating. So that means I need to have something that says either x equals or y equals in one of the two equations. So we look at what we were given here, and we have x equals 5, x plus y equals 12. Well, this one already is isolated for us. It says x equals 5. Okay, so that's our first step, is taken care of. The second step is to substitute that number, or that expression. I'm going to say expression because it's not always a number. Sometimes it's numbers and letters. And I'm having trouble writing it again. Sorry. Substitute that expression for the same variable in the other equation. In the other equation. And I'm sorry that's doesn't look very good, but that says equation right there. Okay? So let's take a look at what that means. We have x equals 5. And since I know that x equals 5, I can take this 5, just like I did with the buttermilk, and I can substitute it for this x right here in the second equation. So instead of x plus y equals 12, I'm going to substitute 5. And when I substitute, I like to use parentheses. 5 plus y equals 12. Now, the parentheses aren't absolutely necessary in this one, because 5 is going to be 5 no matter what. But as we get forward, the problems will get a little harder, and you want to substitute with parentheses. It will make your life easier. So anyway, we have 5 plus y equals 12. How do I get y by itself? I'm going to subtract 5 from both sides, and I get y equals 7. So I think let's add to step 2. Substitute that expression for the same variable in the other equation and solve it. Okay, and solve it. So include that on step 2. Okay, well, now that I know what y is, I'm going to erase this a little bit. Now that I know what y is, we can figure out what x is, because if y equals 7, I can take that and I can do the same thing and substitute it for y in the other equation. So that's going to be our step 3. Substitute your answer for the variable in the original equation. I'm sorry I'm overlapping on these notes, but I have to write big on this iPad. So we're going to substitute substitute the answer for the variable in the original equation. So here's our answer, y equals 7, and we're going to substitute that for y in the first equation. So now instead of x plus y, we're going to say x plus 7 equals 12. Now how do I solve for x? Let's subtract 7. And we get x equals 5. And that brings us to the final thing, which says show your answer. The solution should be written as a coordinate pair, which means an x and a y. So our solution here would be 5, 7. We'll show that as a pair, and there's our answer. Now, if you want to check to make sure you did it right, substitute both of these numbers back in the original equation and make sure they come out. So this is x, so I'm going to put x in the first equation. I get 5 equals 5. Is that true? Yes. In the second equation, we'll put 5 in for x plus 7 in for y, and that equals 12. Does 12 equals 12? Yes, so it checks. Plug them back in and check your work. Okay, now let's try the second one. Why don't you try that yourself? See if you can substitute. Think about what you're going to do. You're going to take, remember, we always want something that says either x equals or y equals, and when we look at this equation, we see one of them is already solved for y. So substitute that and get your answer. See how you do. Okay, so I hope you plugged in 2 for y, and then we subtract 2 from both sides, and negative 8 minus 2 is negative 10. And so we get negative 10 comma 2 as our solution. If we want to check our work, we would say negative 10, that's x, plugging that in for this x, plus 2 equals negative 8. Is that true? It is. So there we go. Let's try the next one. Now again, we already have an equation here that's been solved. It says y equals 2x. So if y equals 2x, I'm going to plug 2x in for y in the second equation. So we're going to substitute it and then combine like terms. And then divide by 5, and we get x equals 2. Now that I know that x equals 2, I can take this 2 and plug it in to the equation above. So we'll say y equals 2 times 2. So you get y equals 4. And there's our solution, 2 comma 4. Now I want to ask you a question. What do you think would have happened if I had taken this 2 and plugged it in for x in the second equation instead of the first? Well, let's see what happens if I do that. 3 times 2 plus y equals 10. So I get 6 plus y equals 10. Subtract 6, and you get y equals 4. Ha ha! So it doesn't matter. Once you've solved one of these, if you plug it back into the other equation, you'll get the same answer either way, because math is cool. Okay? That is very cool. You can use either equation, you'll get the same answer. Now, let's try number 3. Okay, so again, on this one, the equation already says x equals 3y. So since x equals 3y, we're going to plug 3y minus 2y equals 4. What is 3y minus 2y? 1y equals 4. Now take that 4 and plug it back in, substitute it for y in either one of the other equations. So I can say x equals 3 times 4, which means x equals 12. Or I could say x minus 2 times 4 equals 4. This one's plugging it into the first equation. This one's plugging it into the second equation. So we get x minus 8 equals 4. Add 8 on both sides. X equals 12. So once again, you can see you get the same answer either way, no matter which equation you put it into, because math is cool. Now, let's look at number 4. And before we do number 4, we're going to make a quick little change on your paper. I want you to look at the second equation. It says 2x plus y equals 15. We're going to take that 15 and we're not going to use it. We're going to say it equals 25 instead of 15. Okay? So just change your second equation to be 25. Now, this one's a little more tricky because it says x equals y plus 5. So we're going to take this whole thing. This is what x equals, y plus 5, and we're going to plug it in for x in the other equation. So again, you're always going to use parentheses. This is where it really becomes important because y plus 5, all of that is getting multiplied by 2. So we have y plus 5 plus y equals 25, because we changed that 15 to a 25. Now we need to distribute. That's why it's important to use the parentheses. 2y plus 10 plus y equals 25. Now let's combine like terms over here. I have 2 y's and I have 1 y. How many y's we got over there? 3y. So 3y plus 10 equals 25. Now let's subtract 10 from both sides, and you get 3y equals 15. Divide by 3, and y equals 5. Now that I know that y equals 5, let's plug that back into one of the other equations. And when you're trying to decide which one to plug in, I always just look at them and see which one looks easiest. And I'm going to use the first one. So x equals, and instead of y plus 5, we're going to put 5 plus 5. I'm substituting 5 for this y right here. So x equals 10. And so there's our answer. We got 10, 5. And that's our solution. If we were to plug 10 in for x and 5 in for y in both equations, it would come out true on both of them. That's why we call it a solution. Bam! Okay, now you try it on the next one. Why don't you hit pause on the video and see what you can do with it. Okay, so I hope you did that yourself. So I'm going to walk you through my answer. The answer was 3, negative 4. That's the solution to this system of equations. But let's look at the process. First of all, I see that y equals 2x minus 10. So I'm going to take that 2x minus 10 and I'm going to substitute it for the y in the other equation. So 4x minus 3, and in parentheses I'm going to put 2x minus 10. I'm replacing the y with 2x minus 10 equals 24. On our next step, I had to distribute the negative 3. So negative 3 times 2x is minus 6x, and negative 3 times negative 10 is positive 30. The next step, I combined like terms. 4x minus 6x is negative 2x. So I have negative 2x plus 30 equals 24. Then I subtracted 30 from both sides. And so we have negative 2x equals negative 6. And then divide each side by negative 2, and we end up with x equals positive 3. Now, once I know that x equals positive 3, I look back at my original equations, and I decided to use the second equation, which is right here, to substitute 3 in for x. So y equals 2x minus 10, so then I put the 3 in for x, and so you get y equals 6 minus 10, And so y equals -4. And there's your answer. Okay, let's pop on to the back. I would like you to try number 5 yourself. Give it a try, see what you can do with it. Yeah, and you're gonna maybe come up with something a little odd on it. So see what you can do, and then we'll talk about it. Okay, so what happened here is that when I took the y equals 2x plus 3 and substituted it in for the y in the other equation, solved it out, and look at what happened. We had -4x and +4x in the same equation, and so the x's disappeared, and we ended up with 6 equals 6. Now when that happens, when your variable disappears that way, so actually both variables are gone, if you end up with a true statement, so when you get the same number, we're going to say that that's an infinite number of solutions. Infinite number of solutions. Now let's try number 6, because something similar is going to happen on this one. We see that x equals 2y minus 4, so you're going to substitute that for the x in the other equation. So 3 times 2x minus 4 minus 6y equals -12. Now let's distribute. We get 6x minus 12. Not 6x, 6y. What am I doing here? That should have been a y. 6y minus 12 minus 6y equals -12. So now I have 6y and minus 6y. Those cancel each other out, and I'm left with -12 equals -12. Okay, well that's true. They do equal each other. Actually, it came out the same. When you have -12 equals -12, that's going to be infinite solutions. Now, I was hoping there would be an example on this paper where when we figured it out, we ended up with something like this, like -6 equals -12. If your variables go away and you end up with two things that don't match, that means no solutions. So hopefully we'll get one like that sometime soon. Okay, on this next one, we've got to set up the systems. It says the length of the rectangle below is twice the width. The perimeter of the rectangle is 36. Find the length and width, and you need to set up a system of equations and use this substitution. So look, anytime we're finding the perimeter, we're going to say 2 lengths plus 2 widths will equal the perimeter. So in this case, it would be 36. The second equation says the length is, where does it say that? The length is twice the width. So we could say this, the length is L equals 2W. And there's your two equations. Now you can use substitution to solve it. So I'm going to hit pause, and I want you, now that it's set up, you try and solve it and see what you do. So note, I want you to notice that when we do perimeter questions that are in the systems unit, they're always going to be set up this way. 2L plus 2W equals 36. And then the other equation is going to be based upon the relationship between the length and the width. Okay, so now that we have the equations, we can use substitution. So you can do 2 times 2W plus 2W equals 36. I substituted 2W in for L. So 4W plus 2W equals 36. 6W equals 36. Divide by 6. And W equals 6. So the width equals 6. And so to find the length, remember the length is equal to 2 times W. So the length is equal to 2 times 6. So that equals 12. So So the width is 6, the length is 12. And we could show that as a coordinate pair, 6, 12. If I'm using letters that are not X's and Y's, I always do my coordinate pairs in alphabetical order. L comes before W, so there I did. I just told a lie. I told a lie. So that should be 12, 6, the length and the width. Bam. Okay, number 8. The length of the rectangle is below is 10 feet longer than the width. The perimeter is 48. So we want to set up a system. So the perimeter is always going to be 2L plus 2W equals, and what is the perimeter on this one? 48. Now the second one is the relationship. The length of the rectangle below is, so L equals 10 feet longer than the width, so W plus 10. Okay, so now we can use that information to solve the equations. So I'm going to take this W plus 10 and substitute it for L in this equation. So 2 times W plus 10 plus 2W equals 48. 2W plus 20 plus 2W equals 48. So we have 4W plus 20 equals 48. I just combined like terms. Subtract 20. 4W equals 28. Divide by 4. And W equals 7. Well, if W equals 7, then L equals W plus 10. Put the 7 in for W. And we get L equals 17. Now, one thing I forgot to mention on the last problem, on these perimeter problems, a good idea would be maybe to put your answers into the rectangle and then add them up and make sure they equal what the perimeter is. In this case, it needs to equal 48, and if you add those up, sure enough, it equals 48. That might be a nice way for you to check to make sure you did everything correctly. The other thing would be to take your 7, your 17 and your 7, your coordinate pair, and you could plug those in to your original equations and make sure they can come out true. All ways that you can check your work. Okay, so that's your first lesson on substitution, and hope it goes well for you on your homework. Bye.